Good afternoon everyone. Myself is Parminder Kaur from Government Polytechnic College for Girls, Jalandhar, and my topic is Integration of Trigonometric Functions. Before solving the questions, we first discuss some of the results that we are going to use in our questions of trigonometric functions. The first result that we are going to use is, first of all, write down the results. First result is integral of sin x dx. This is equal to minus cos x plus c, where we know c is a constant of integration. In the last lecture, you have studied that integration is the inverse of integration. That is why the integral of sin x dx is minus cos x plus c, because derivative of minus cos x is equal to, by taking minus sign outside, we know already that derivative of cos x is minus sin x. This minus minus becomes plus sin x. Since derivative of minus cos x is sin x, therefore, the integral of sin x is minus cos x plus c. This is our first result. Second result, integral of cos x dx. This is equal to sin x plus c, because we know derivative of sin x is cos x. Sin x is cos x. Third result, integral of secant square x dx is equal to tangent x plus c, because derivative of tangent x we have already done is secant square x. Therefore, the integral of secant square x is tangent x plus c. Result 4 that we are going to use is integral of cosecant square x. This is equal to minus cotangent x plus c, because derivative of minus cotangent x, this can be written as this, minus sign, taking minus sign outside, and derivative of cotangent x is cosecant square x. Minus minus becomes plus cosecant square x. Since the derivative of minus cotangent x is cosecant square x, therefore, the integral of cosecant square x is minus cotangent x plus c. Fifth result that we are going to use is secant x tangent x integral. This is equal to secant x plus c, because derivative of secant x we know is secant x tangent x. And sixth result is integral of cotangent x cosecant x dx is equal to minus cosecant x plus c, because derivative of minus cosecant x, this can be written as taking minus sign outside, and the derivative of cosecant x we know is minus cosecant x into cotangent x. Minus minus become plus, this is cosecant x cotangent x. Since derivative of minus cosecant x is cosecant x cotangent x, therefore, integral of cosecant x cotangent x is minus cosecant x plus c, where c I have already told you that it is a sign constant of integration. Another thing that we must remember, write down the first note. Angles in the trigonometry function that we have studied, that are measured in radians. Angles are measured in radians. In questions where we have to integrate the trigonometry function, the angles should be in radians. If it is not, first we will change into radians and then only we have can integrate. In questions, this is going to be very helpful to integrate powers and products of trigonometric functions. We transform the integrand into fundamental integrable form with the help of AB formula. These formulas we have already studied in first semester trigonometry, and multiple and submultiple angle formula of trigonometry. What does it mean? That if in questions we have the integrate as powers or product of trigonometric functions, first of all we will change them into the integrable form with the help of AB formula we are going to use, and multiple and submultiple angle formula of trigonometry. Next, there are 4 standard integrals. That is, first is integral of tangent x dx. We know that tangent x can be written as sin x over cos x. In last lecture, we have studied that integral of f dash x over f x into dx is equal to log of f x. What does this result mean? If in the numerator we have a function and if in denominator we have the function and in numerator is its differentiation, then the integral of that function is log of f x. Now, here in this question, in denominator we have the term cos x, because derivative of cos x we know is equal to minus sin x. Therefore, we can write the integrand as minus into minus, minus becomes plus over cos x into dx. Now, in denominator it is function cos x and in numerator is its derivative, that is minus sin x. Then according to this result, this is equal to minus log mod of cos x plus c, where c we know is a constant of integration. The second result is integral of cotangent x dx. We know cotangent x can be written as cos x over sin x. In denominator we have the function sin x, in numerator is its derivative cos x, because d dx of sin x we know is cos x. Then according to the previous result that we have written, the integral of this is log of mod of sin x plus c. Third result, this is integral of secant x dx. Now, for this what we do in the first step, we multiply and divide by factor secant x plus tangent x. Secant x plus tangent x, multiplying and dividing by secant x tangent x. What we have done? Multiply and divide by secant x plus tangent x. Now, let us see in the numerator what we have. Let us open the bracket. Secant x into secant x we know is secant square x secant x into tangent x plus secant x tangent x. In denominator we have secant x plus tangent x dx. Now, because derivative of secant x we know is secant x tangent x, and derivative of tangent x we know is secant square x. In the denominator we have the function secant x plus tangent x. Now, derivative of secant x is secant x tangent x, and derivative of tangent x is secant square x. Denominator we have the function, in numerator is its derivative, then this integral becomes log of secant x plus tangent x plus c. Fourth result is integral of cosecant x. In this we multiply and divide cosecant x by the factor cosecant x minus cotangent x over cosecant x minus cotangent x into dx. What we have done? Multiplying and dividing by factor cosecant x minus cotangent x. Now, in numerator it becomes cosecant x into cosecant x as cosecant square x minus cosecant x into cotangent x, and in denominator we have the functions cosecant x minus cotangent x into dx. Now, we know derivative of cosecant x is minus cotangent x into cosecant x, and derivative of minus cotangent x is minus cosecant square x, minus minus become plus cosecant square x. Now, what is this? Derivative of cosecant x is minus cosecant x cotangent x, and derivative of minus cotangent x is cosecant square x. In denominator we have the function, in numerator is its derivative, then according to the result this integral of this is log of mod of cosecant x minus cotangent x plus c. We can further solve this as, we can write this as log of mod of cosecant x we know is 1 over sin x, cotangent x is cos x over sin x. Taking LCM, sin x as LCM, we have sin x, in numerator we have 1 minus cos x plus c. Now, we have studied two results, of one of cos 2x and one of sin 2x. We are going to use here that results. The results that we are going to use here are cos 2x as 2 cos square x minus 1, and sin 2x we know is 2 sin x cos x. Now, we were doing this question, here instead of 2 it is x, then according to this result if it is on the left hand side the angle is 2x, on the right hand side the angle becomes half. Now, here in numerator we have 1 minus cos x, this means integral can be written as 1 minus 2 cos square x by 2 minus 1, and in denominator we have sin x, then sin x becomes 2 sin x by 2 cos x by 2 into dx. This can be written as, sorry, we were just substituting the values, the integral was log of mod of this plus c, correct this. This is log 1 minus 2 cos square x by 2 minus minus, when we open the bracket, minus minus will become, we have the question, let us repeat it again, there is some problem in this question. This is log, we have done integral of cosecant x, then we have done the integral of cosecant x as log of cosecant x minus cotangent x. Cosecant x can be written as 1 over sin x and cotangent x as cos x over sin x. Taking common LCM sin x, we have 1 minus cos x. Now, here we are going to use this result as 1 minus cos 2x. We are going to use this result 1 minus 2 sin square x, and sin 2x, as we have already done this as 2 sin x cos x. We have the function log of 1 minus cos x over sin x. This is equal to log of mod 1 cos 2x is 2 sin square x, it is here angle is x, we will make the submultiple angle minus 1 minus 2 sin square x by 2, and in denominator it will become 2 sin x by 2 cos x by 2 plus c. This can be written as log 1 minus 1 minus minus will become plus 2 sin square x by 2, in denominator we have 2 sin x by 2 cos x by 2 plus c. This is plus 1 minus 1 cancels, in numerator we have 2, denominator we have 2, 1 sin x by 2 cancels, we are left with log mod of sin x by 2 over cos x by 2 plus c. We know sin theta over cos theta is tangent theta. This is log of mod of tangent x by 2 plus c. Let us repeat this, what we have done. Integral of cosecant x multiplying and dividing by cosecant x minus cotangent x. Then we know this is in denominator we have the function, in numerator is its derivative, then this is integral of this function is log of cosecant x minus cotangent x. Changing cosecant x and cotangent x in terms of sin x and cos x, we get 1 over sin x minus cos x over sin x. Taking the LCM, here we are going to use submultiple angles, cos 2x as 1 minus 2 sin square x, sin 2x as 2 sin x cos x, here angle is x, it will become half. In denominator also the angles will become half, cancelling 2 sin x by 2 and 2 sin x by 2 from numerator and denominator, we left with sin x by 2 cos x by 2, and this we know is tangent x by 2 plus c. Now, we are going to use all these results in our questions. Now, let us do the questions first. Write down the statement of the first question that we are going to discuss. Evaluate integral of cos square x dx. Solution, let I integral is equal to cos square x dx. Now, the integrand is in the power form. We are going to reduce it by making use of multiple and submultiple angles that we have done in our note. Because cos 2x we know is 2 cos square x minus 1. Therefore, 2 cos square x, taking 1 to the left side, this becomes 1 plus cos 2x, or cos square x is equal to 1 plus cos 2x over 2. What we are going to do? We are going to replace cos square x dx by 1 plus cos 2x over 2. I integral becomes integral of 1 plus cos 2x over 2 into dx. Now, we are integrating this with respect to x. 2 is our constant term. We can take constant term outside the sign of integration. This becomes 1 by 2 integral of 1 plus cos 2x into dx, and this can be written as, we can integrate term by term, integral of 1 plus integral of cos 2x. In last lecture we have studied that integral of 1 is x. Now, today we have studied that integral of cos x is sin x. Here we have the function cos 2x and the integral of cos 2x is sin 2x over 2. Now, we know that in differentiation we used to multiply the function by the derivative of the angle. Since integration is the inverse of differentiation, we have divided the function by the derivative of the angle. In this, the angle was 2x, constant into variable, that derivative is constant term, and the derivative, that is 2, we have divided the function by that term, plus c, where c is a constant of integration. Let me quickly repeat what we have done in this question. We have placed cos square x by 1 plus cos 2x over 2, taking 2 outside the sign of integration, then integrating term by time. Integral of 1 is x and integral of cos 2x is sin 2x over 2 plus c, or we can write this as x by 2 plus sin 2x over 4, taking 2 inside, 2 into 2 is 4 plus c. This is its answer. This was our first question. Now, let us do second question. Write down the statement of second question. Evaluate integral of 1 plus sin x. Solution: let I be equal to integral dx over 1 plus sin x. Now, we have term 1 plus sin x in the denominator. In first step, what we are going to do is to rationalize it, but you know the meaning of rationalize. Rationalize means multiplying and dividing by the opposite sign that we have in the denominator. We multiply numerator and denominator by the factor 1 minus sin x. This is equal to 1 minus sin x. Denominator we have the term 1 plus sin x into 1 minus sin x, that is a plus b, a minus b. We know this is equal to a square minus b square. Here a is 1, a square means 1 square is 1 minus b square. What is b here? Sin x, sin square x into dx. This can be written as 1 minus sin x. We know 1 minus sin square x is cos square x. Now, separating the terms, first term is 1 over cos square x dx, integral of first term, in between sign is minus, integral of second term, that is sin x over cos square x into dx. Now, we know 1 over cos square x is secant square x dx, sin x. In denominator we have term cos square x. Cos square x can be written as cos x into cos x into dx. We know that the integral of secant square x is tangent x. In second integral we have sin x over cos x. Sin x over cos x is tangent x. 1 over cos x is secant x into dx. This is equal to tangent x minus, we have studied the integral of tangent x into secant x is secant x, get this as plus c, where c is a constant of integration. Let us repeat the steps now. In first step we had done rationalizing the term by multiplying and dividing by the opposite sign what we have in the denominator. In denominator we have 1 minus sin square x, that is cos square x, then integrating term by term, first term becomes secant square x and the integral of secant square x we know is tangent x. In the second integral, in denominator we have cos square x, we split cos square x as cos x into cos x, sin over cos becomes tangent and 1 over cos x is secant x and integral of tangent x secant x is secant x. Thus, we get the answer as tangent x minus secant x plus c, where we know c is a constant of integration. Now, third question, evaluate sine x degree dx. Solution, let us take this integral as I equal to sine x degree dx. Now, in the note we have done that the angles are always measured in radians, but here we have the angle in degrees. First of all, we will change this degree into radians and then only we can integrate. Now, we know the relationship between degrees and radians because 180 degree is equal to pi radian, or we can say 1 degree as pi over 180 and x degree becomes pi x over 180 radians. Now, I becomes integral of sine pi x over 180 into dx. Now, we know this integral of sine is minus cos pi x over 180 divided by the derivative of the angle. What we have our angle? We have angle pi x over 180 and derivative of pi x over 180. Pi over 180 is our constant term, x is our variable, constant into variable is derivative is pi over 180. So, we have to divide by which term? Pi over 180 plus c, or taking 180 in the numerator we can write this as minus 180 over pi cos pi x over 180 plus c. So, what we have done in this question, we change degrees into radians. X degree we know is equal to pi x over 180 radians. Integral of sine x is minus cos x divided by the derivative of the angle, and derivative of angle is pi over 180. In next step I do done taking 180 in the numerator and pi in the denominator, we get the answer as minus 180 over pi cos pi x over 180 plus c. Write down next question. Evaluate integral of 1 plus sin x dx. Solution, let I integral is equal to under root 1 plus sin x dx. Now, in square root we have 1, we can write 1 as cos square x by 2 plus sin square x by 2 as 1, and sin x we know the formula of sin x is 2 sin x by 2 cos x by 2. The I integral becomes integral, instead of 1 we write cos square x by 2 plus sin square x by 2 plus sin x. Sin x can be written as 2 cos x by 2 sin x by 2 into dx. Now, let us see what it becomes. Square root, this is if I take cos x by 2 as a, sin x by 2 as b, this is a, this is b. What does it become? A square plus b square plus 2ab, and we know this is the formula of a plus b whole square. We have a as cos x by 2, b as sin x by 2 whole square into dx. Know that square and square root cancels, we left with cos x by 2 plus sin x by 2 dx. Now, we integrate term by term, integral of first term cos x by 2 plus integral of second term sin x by 2. Now, we have the function, trigonometric function cos x by 2, and we know the integral of cos is sin x by 2 divided by the derivative of the angle. Here we have the angle x by 2 and derivative of x by 2 we know is 1 by 2, and integral of sin x is minus cos. This will become minus cos x by 2 divided by the angle, that is x by 2, and derivative of x by 2 we know is 1 by 2, plus c, where c is a constant of integration. In the next step, what we do, take 2 in the numerator, it becomes 2 sin x by 2 minus 2 cos x by 2 plus c. This is our answer. Let us repeat the steps what we have done. Replaced 1 by cos square x by 2,